Alright, this is homework 6, question 5. Says a stone is thrown at an angle of 36.9 degrees above the horizontal at 24.0 meters per second from a building 56 meters high. Overall outline for the problem is what is the maximum height with respect to the ground that the stone reaches. Find the following just before the stone hits the ground: Vx, Vy, V, and theta. C, how many seconds does it take for the stone to reach the ground? And then D, how far from the base of the cliff does the stone strike the ground? So I think we're going to hit A and B, and then maybe C and D in a second part. So I'm going to change the values here just because, and I'm not going to hit 45 because I don't want to. I'm going to change it to 30 degrees. So if I draw this on here, I'm going to say this is the triangle representing my initial velocity. I'll label that 30 degrees. And instead of having it launched at 24 meters per second, let's say it's launched at 36 meters per second. I've not done this problem before. And then from a building 56 meters high, right? So let's change 56 to, let's say 27 meters high. All right. So when I go ahead and set this up, I'm going to draw a picture, and it's going to look something like this. Here's my building. All right, my stone is going to go up and then strike the ground. I probably shouldn't have that as straight a line at the end, but it's just a picture. Alright, so let's see, this is 27 meters here. And then I am going to say my velocity at the top in the y direction is 0 meters per second. Why is it 0 meters per second? Because if it were any greater or any less, it would be on the way up or on the way down. And at the very top, it's obviously not moving up any further. It's only going to move down after that. So the first thing we want to do after that is go ahead and resolve our triangle from the beginning into its components. So this is my resultant velocity, or the velocity it's fired at initially. I want to break that into its velocity within the y direction, Vy. I'm going to call that Vy initial. And then velocity within the x direction. Alright, so in the y direction, if you watch the other videos, I'm just going to go ahead and say Vyi equals 36 meters per second times the sine of 30 degrees. I'm not going to work it out further and say, oh yeah, this is why we do that, because if you guys got this far on the homework, you should know that. If you didn't get this far on the homework on your own, go back and check the other ones. It's explained in there. So Vy initial is 36 times sine 30, which should give us 18. There we go. So that's 18 meters per second in the y direction initially. Alright, so if we want to solve for Vx, it's going to end up being 18 times the square root of 3 because of the triangle. But anyways, we're going to say Vx equals 36 meters per second times the cosine of 30 degrees. And that's going to be 31.18 meters per second. And I'm going to label my drawing so that I can glance at that and see immediately what it is. So overall, I'm looking at this, and what are we looking for again? Maximum height with respect to the ground that the stone reaches. I'm going to write down a bunch of stuff within the y direction. At this point, when we're looking at the maximum height above the ground that the stone reaches, we really don't need anything that's happening in the x direction right now. We can treat it as a problem that essentially says a stone is thrown into the air at 18 meters per second, straight up. How long does it take to reach the ground? What's the maximum height above the ground? So a couple things here. When I'm putting everything down for my y direction, I'm going to say y initial equals 27 meters, okay? I do not know my y final. That's what I'm looking for, y sub f. Okay, and I'm going to put y sub f equals question mark. Now, that is going to be my maximum height with respect to the ground, okay? Delta x, or delta y in this case, is equal to my final position, this one, minus this one. If it were going down and I were looking at the overall problem from here to here, I would have a negative velocity for delta y. But for this part, my delta y is going to be positive because I'm ending up here and starting here. So I'm going to say delta y equals y final minus y initial. And I'm going to go ahead and put in 27 meters for y initial and leave y final as y final because I do not have a value for that yet. So delta y equals yf minus 27 meters for this part of the problem. I do know that acceleration is negative 9.8 meters per second squared due to gravity. I do not know the time that it takes to get there. I also know that my velocity at the beginning, velocity initial, equals 18 meters per second, and my velocity at the top equals 0 meters per second. I did this last problem, but something I want to note for this part is that right now, again, we're going to actually solve more of this later on, but right now we're only looking at this part of the problem because we want to know how far up it goes. So if we look at everything in the dashed red box here, starting off here with a velocity of 18 meters per second, and I'm ending here with a velocity of 0 meters per second. All right. So, which kinematic equation do we want to use? We want to use delta y. We want to know how far it goes. That's going to have how far it goes wrapped up into it. So I do not want to use time. So I'm going to use acceleration, velocity initial, and velocity final. If we look at our kinematic equations, the one that does not include time, because I'm not going to use that one, is going to be my third. Vf squared equals vi squared plus 2a delta y. That is hands down going to be the best kinematic equation to use on this one. Alright, so I'm going to say Vf squared equals vi squared plus 2a delta y. At this point, I want to bring up something. Do we have delta y in terms of anything else? Yes. Okay. So if I want to know my final velocity, I'm going to plug this in for this. If I don't do that, then I run a high risk of finding delta y and then saying I'm done with the problem, but in reality what you'll have done is only found that height. By plugging in yf minus 27 for delta y, what we're going to find is the final height above the ground, not just the final height that it goes above the top of the building. So Vf is 0, so that's 0 meters squared per second squared, equals velocity initial is 18 meters per second squared, plus 2, acceleration due to gravity is negative 9.8 meters per second squared, times, move it over here, delta y, and that's going to be yf minus 27 meters. There we go. Alright, so let's see. I'm going to go ahead and move 18 meters per second squared to the left side and square it all in one step. So I can put some room in here. So 18 squared gives us 324. So that's minus 324 meters squared per second squared equals negative 2 times negative 9.8 is negative 19.6 meters per second squared, and that's going to be multiplied by yf minus 27 meters. And I'm not going to distribute that because that would be pretty crazy. I would have to then subtract it out anyways, and then I would divide. I'm not going to do that. What I am going to do is go ahead and divide the whole thing by negative 19.6 meters per second squared. Divide both sides by that, 19.6 meters per second squared. I want to point out something here too. I'm including my units in here, and part of the reason I'm including my units all the way, it does make it messier while you're working through the problem, but I know that when I cancel stuff out, I'm ending up with the proper unit if I do it correctly, and in this case I am. So seconds cancels out. Instead of meters times meters, it's just going to be meters because one is going to cancel out with meters on the bottom. Per second squared cancels out top to bottom. Positive, or my negatives turn to positive. So I'm going to get 324 divided by 19.6 gives me 16.53. So 16.53 meters is equal to YF minus 27 meters. Alright, my units match up, so I must have done everything properly up to this point. Plus 27 meters, plus 27 meters, cancels out on the right side. So I get my final height is 43.53 meters. And I know that that is with respect to the ground, not with respect to the top of the building, because I solved for it here and included it in the equation. Alright, I'm actually going to go ahead and stop it here and continue with the next part in another video.